want to revisit the mean, the concept behind it. And I'm going to introduce this as taking a look at almost like a balance. And when we get into weighted balance, weighted means, hopefully that'll make a little bit more sense to you. Now, if we have three equal masses, and we're going to put one at 2 centimeters, one at 18 centimeters, and one at 25 centimeters, well, the average here would be 15. And this makes sense because if we take a look at the block that's 2 centimeters away, well, it's 13 centimeters from the fulcrum. And the 18 centimeter is 3 centimeters, and the 25 is 10 centimeters. So we have 3 and 10 to the right and 113 to the left. So it makes sense that the average or the fulcrum should be at 15 centimeters. Now, what I want to talk about now is the deviation of this. So the more spread out values are from the mean, we say it has a greater deviation from the mean. So if we take a look at this, the deviation from the mean of the 2 centimeter would be 13. And we could say it's negative 13 because it's to the left. And to the right, we have a deviation of 3 for the 18 and a deviation of 10 for the 25. Now, I'm going to introduce the concept of weighted mean, and I'm hoping that this little example just might help us with, or help you with understanding the concept of a weighted mean. So let's say in this case, instead of the masses all having the same mass, let's say that at the block at 2 centimeters is 10 grams, the block at 18 centimeters is 15 grams, and the block at 25 centimeters is 12 grams. So now it's not as though they're all equal. The question is, where would you place the fulcrum now? And the simplest way to do this is imagine that you have 37 identical 1 gram blocks. We're going to stack 10 at 2 centimeters. We're going to stack 15 at 18 centimeters and 12 at 25 centimeters so that's our 12 grams, our 15 grams, and 10 grams. Now, what we can do is multiply the distance from the on the balance by the mass number. And so 2 times 10, 18, at 18 centimeters, we're going to have 15. And at 25 centimeters, we're going to have 12. And so then what we can do is find the average of this. And so the weighted mean would be then this mean of our sample here would be 590 divided by 37. And so therefore you would place the fulcrum at 15.95 centimeters. Now, in general, a weighted mean can be calculated as the mean, and in this case, I'm arbitrarily saying it's a sample. So the mean is equal to the sum of all the values times the weight. And we divide that by the sum of the weights. And we'll give you an example here just to hopefully give you a little bit better idea. And once we drop this, so this is just basically the values times the weight divided by the sum of the weights. So the sum of the values times the weight divided by the sum of the weights is equal to our mean for when we have weighted data. Now, suppose a teacher weighs a student's marks in her final calculations as follows. Knowledge and understanding is 25% of the mark, application is 15%, problem solving is 20%, and communication is 10%, and the final exam is 30%. The students' marks in these categories are 78, 75, 80, and 85 respectively, and the final exam has not yet been written. So that what we're going to do here is to calculate the term mark before the final exam. So we're going to use the formula. And so again, I'm using this to hopefully explain what this means. So in here, X would represent the mark for each of these categories, and W would represent the weighting for each of these categories. So the sum of the product of the mark times the weight divided by the sum of the weights. And so we calculate that by 78 times 0.25, which is the mark of 78 times the weighting for knowledge and understanding, then 75 times the weight for application, which is 0.15, a mark of 80 in problem solving times the weight for problem assigned for problem solving, plus the mark for communication of 85 times the weighting for that communication mark. So then what we divide by is the sum of the weights. And in this case, we get an answer of term mark of 78.9. So part B wants you, if the term mark of 78.9 is worth 70% of the final exam, final mark, and the final exam is worth 30%, student wants a final mark of 82. What mark is needed on the final exam? Now, we could calculate the final mark on the exam would be 0.30 times the exam mark. And we know that the weighting here is 70% of the term mark, which is going to be 78.9. That's the mark that they're going in with. And so that when we rearrange this and solve for E, you get an answer of 89.2. So the student would need to get a mark of 89.2% on the final exam if they're going in with a term mark of 78.9 to end up with a final mark of 82%. So this here is just rearranged the equation. We to get E all by itself, you subtract 0.7 times 78.9, and then you divide by 0.3. Now, more importantly, we looked at group data previously when we were working with Excel. So if we're given group data in a situation like this, and we want to calculate the mean age. So if we've got, this question is the age of people that when they first bought got their first car. So between 16 and 20, 10 people said that they got their first car. Between 21 and 25, 18 people said they got their first car, and so forth. So now the question is, how do you calculate the mean of this data? Well, very similar to what we did before. It's the exact same concept as when we find the weighted average. And we're going to use now the midpoint of the interval as the data value. So for example, for 16 to 20, we're going to say the midpoint here is going to be 18. So what we do is we take the frequency and times it by the midpoint of that age group. So then as we do that, we find, for example here, for 31 to 35, 8 people got their first car. The midpoint of that is 33, so we take 8 times 33, and then what we're going to do now is take the sum to calculate the mean. We're going to take the sum of the frequency times the midpoint, and at the end what we're going to do is divide by the sum of the frequencies. Okay, so in this case here, so F times M, so this first 180 is from up at this table. It's the frequency of 10 times the midpoint age of 18, so we get 180. So we add up all of these values from this table, and then what we do is divide by the sum of the frequencies. So here the frequencies are 10, 18, 12, 8, and 2. And so we find that the mean age for getting your first car, according to this group data, is 25.4.